Okay. Today's another problem is from the function and relation, and that question is prove that the given function is bijective. Given function like bijective show garन्छ and the question is defined by f such that from r minus 3 to r minus 1 given by f of x equals to x minus 2 over x minus 3. This function is bijective. This is to be proved. And by definition, we have known that bijectivity of the function means injectivity and sorority of the function exist, right? That function must be injective function and surjective function both. That proves the bijectivity of the function. So now we observe the set of domain and set of codomain over here in this function. First of all, we have to observe the set of domain and set of the codomain under the given function. What are the domain and what are the codomain, right? And we see here with our naked eye, right? We see here with our naked eye, this domain is the set of real number except 3. We see that. And this second set is, this is second set. This is the set of codomain, right? This is set of codomain, and codomain is the set of the real number except 1. In the codomain, 1 is not there, 1 is excluded, and the domain 3 is excluded, right? So to prove the bijectivity of the function, first of all we prove its injectivity. So for injective or for one-to-one solution f of x equals to what are we given here? X minus 2, this all over x minus 3, right? And this f such that from r minus 3 to r minus 1. So we need to write this in full. Okay, first of all we observe this mapping diagram. This is the set of domain, this is the set of codomain, right? And these all elements are which are belonging in the first set, these are the domains. And these components, these elements which are belonging in the second set, these all are said to be codomain. Keep in mind, right? This domain, these all are codomain. These domain are also called a pre-image, and these elements which are belonging in the second set, these whole elements are said to be codomain. And those elements which are mapping with the element of the first set, these are range. This is range, right? This one is range, and this component is not mapping here. This is not mapped over here, right? So with the 1, 2, 3, these 3 are range. This is not range. These all are codomain, right? These all are codomain. Whether these are mapped or not, that does not add a matter. These the whole elements are said to be codomain, and those elements which are mapping with the element of the first set, they are said to be range. And we need to prove the injectivity of the function. So to prove the injectivity function, injectivity of the function is also called a one-to-one function, one-one function. Now, what type of function is said to be one-one function? We have already studied in the previous classes. Different domain have different range. Different domain have different range. Suppose this is 1, this is 2, this is 3, this is A, right? This is B, this is C. This F1, right? This is 1, and F is mapping this one, and finally this becomes F of 1, F of 1 equals to A, and these two become here f of 2 equals to B, and this 3, so this becomes f of 3 equal to C, right? Domain range of this 1 is A, range of this 2 is B, range of this 3 is C, right? C means f of 3, right? No two element have the same image here. यहाँ दुईटा डोमेन को सेम रेंज छैन है, यहाँ दुईटा डोमेन को सेम रेंज छैन. यस्तो भइदिएको भए सपोज 4 थियो अनि यसमा C मा लगिदिएको थियो भने image of this 3 and 4 is C. In this case, image of 3 and 4 is C. Image of 3 and 4 is here C. In that case, the function is not one function. That is not injective function. This is a many to one function. This is a many to one function, many to one हुने थियो है. अब हाम्रो के छ त भन्दाखेरि यो सेक्सन हामीलाई इन्जेक्टिभ प्रुफ गर्न छ. यसलाई इन्जेक्टिभ प्रुफ गर्न यस्तो खालको हुनुपर्छ. त्यसो भए म के गर्छु त भन्दाखेरि we now assume here this component A and B same है. This component and this component same. त यो component र यो component A छ अनि यो component B छ. This image and this image are same. Which pre-images are produced this A? one ले A बनायो, 2 ले B बनायो. अब म के गर्दैछु त भन्दाखेरि I am assuming here this component same. If those two images are same, their respective pre-image must be same. Only then that function becomes injective function. So let x1 and x2 belonging in the domain of f, that is equals to domain in the set of real number x of 3 r minus 3. The value of x1 is not equal to 3, x2 is not equal to 3, right? We are given this x1 is not equal to 3, x2 is not equal to 3, and suppose f of x1 equals to f of x2. What are we assuming here? What are we doing here? We are assuming here these two images are same. If those two images are same, their respective pre-image must be same. F of x1 equals to f of x2. That means x1 must be equals to x2 finally. So fx is defined by x minus 2 over x minus 3. So f of x1 equals to what happens here? x1 minus 2 all over x1 minus 3. This is equals to x2. So replace this x by this x2 minus 2 this all over x2 minus 3. Okay, now what to do from here? We now have to simplify here, and finally our main framework is to get x1 equals to x2. We are assuming that this f of x1 and f of x2, though these are two images, these two images are equal. If images are equal, their respective component, that means pre-image must be same. That means x1 is the pre-image, x2 is the pre-image, those two components must be same. So our main strategy is that to say that x1 equals to x2. So we now simplify. So x1 minus 2 times what happens here? x2 minus 3. This is equals to what can I here? This is equals to x2 minus 2 times of x1 minus 3, right? Okay, by cross multiplying this came to happen here. I am now upon this now, multiply this now. x1 x2 minus 3x1 minus 2x2, this is positive 6, this is equals to, on the right what happens? x2 x1, that means x1 x2, is it right? Be careful. x1 x2 minus what happens? 3x2 minus 2x1 and this negative 2 and negative 3, positive 6. This and this quantity on the left and right cancelled, right? Then positive 6 and positive 6 also cancelled. And remaining on the left, minus 3x1 and this minus 2x1. Transpose this minus 2x1 on the left, that becomes plus 2x1. So finally this is minus x1. This is equals to what can I here on the right, minus 3x2 and minus 2x. Transpose this to the right, minus 2x2 on the right. So those two give minus x2. Therefore x1 equals to what happened here? x1 equals to x2. This was our main framework. So function is injective. So f is injective. Therefore f is injective. That is function is 1. Now next part. Now for onto. Okay. For onto. Okay. Now how to prove the surjectivity of this function? We must have codomain must be equals to range. Let codomain equals to image. Okay, codomain equals to image. What is codomain? Codomain is y. Image is fx, right? Okay, y equals to fx equals to y remains as it is, and fx equals to we are given this x minus 2 this all over x minus 3. Now what to do from here? अब के गर्ने? यो फंक्सन त हाम्रो अन टु हुन्छ अरे, अन टु त हुनै पर्यो, बाइजेक्टिभ हुन्छ भनेपछि त बाइजेक्टिभ प्रुफ गरेर भनेपछि त 1 to 1 एन्ड अन टु त हुनै पर्यो, अन टु फंक्सन त हुनु पर्यो अनि मात्रै बाइजेक्टिभ बन्छ। त्यसो भए मैले के गरेँ त कोडोमा इक्वल टु त हुनु पर्यो नि त यो। अब फाइनल्ली भरे सिम्प्लिफाई गरेर जाँदाखेरि हाम्रो यस्तो एक्स एक्जिस्ट गर्नु पर्यो, त्यो एक्स भनेको यो सेटमा बिलङ गर्नुपर्छ। त त्यो सेटमा बिलङ गरेन भने के हुन्छ त हुँदैन भने फंक्सन अन टु नै हुँदैन। त्यही भएर मैले कोडोमेन इक्वल टु इमेज गरेको छु, कोडोमेन y इमेज fx equal to x minus 2 over x minus 3. Now we solve for x from here. अब यस्तो x आउनु पर्छ, we are searching this x. What kind of x will you get here finally? This function must be onto, so that this function will be onto. So we have to get that. We need to get such type of x which must belong to this set x r minus real number 3. x को value 3 हुन पाउँदैन, 3 भाग जुन सिंगल नम्बर हुन पाउनु पर्यो। So okay, xy minus 3y, xy minus 3y, this is equals to x minus 2. This simplify xy minus x, this is equals to 3y minus 2. So x equals to what happens? 3y minus 2, this all over y minus 1. Now what are you given here? Which one is given? Y is given. Now what is y? Y is that real number except 1. Y को value 1 चाहिँ हुन पाउँदैन है, किन भन्दा y is the codomain is a real number except 1. So y is not equal to, since y is not equal to 1 except y equals to 1, this number x equals to 3y minus 2 all over y minus 1, this falls on real number. That will be real number. Okay, continuously from here, take a look here. Or x equals to, find what have we got here? X minus 2 over y minus 1. Okay, y is not equal to, since y is not equal to 1, since y is not equal to 1, therefore x equals to 3y minus 2, this all over y minus 1, this falls in real number r, except y equals to 1, this number 3y minus 2 over y minus 1, that will be real number. Now you can check whether this is the real number or not. Suppose y equals to 2, y equals to 2, y equal to 2 राख्यो भने कति हुन्छ त भन्दाखेरि 3 into 2 minus 2, this all over 2 minus 1, this is equals to 6 minus 2 4, 4 over 1 equals to 4 bar, this falls in r. Y equal to 0, y equal to 0 setting गर्यो भने यो 0 हुन्छ, y को value 0 राख्न पाइन्छ, the value of y can be 0. So this will be minus 2 over minus 1, that will be 2, that falls in r. हो यस्तो केस आउनु भयो, यस्तो खालको केस आउनु पर्यो। x को भ्यालु कति हुन पाउँदैन, 3 हुन पाउँदैन। हो अब के गर्ने? Since y is not equal to 1, therefore x equal to 3y minus 2 over y minus 1 falls in r. ठीक छ? Moreover, x equals to 3. I am assuming here, ल y को x को भ्यालु 3 हुन पाउँदैन भनेको छ। त 3 गरौँ न के हुँदो रहेछ? 3 नि छ भनेको छ बुझारौ। ल हेरौँ है त, x equals to 3y minus 2 over y minus 1, x यस्तो छ नि त, x equal to यो भयो है, minus 3, cross multiplication happens, 3y minus 2, this is equals to what happens? 3y minus 3, this cancel, this is cancel, so minus 2 equals to minus 3, which is untrue, which is untrue, which is false. Finally, the value of x cannot be 3, but I have assumed x equal to 3 and simplified here, and finally we came to get a contradiction, minus 2 equal to minus 3, that which is false statement, minus 2 equals to minus 3 हुने केस भएन, which is untrue, which is untrue. Therefore, that means, therefore x is not equal to 3, x को भ्यालु 3 हुन पाउँदो रहेनछ x को भ्यालु 3 भएको कारणले यस्तो फल्स स्टेटमेन्ट आएको हो x को भ्यालु 3 हुन पाउँदो रहेनछ त्यसो भए that is x equal to 3y minus 2 over y minus 1 is not equal to 3 हुन पाउँदैन त्यसो भए मैले के गरेको छु त भन्दाखेरि x is equal to this quantity this is real number except y equals to 1 this will be real number मैले अब x को भ्यालु 3 नै सपोज गर्ने x को भ्यालु 3 नै सपोज गरेर फल्स स्टेटमेन्ट आए त्यसो भए x को भ्यालु 3 छैन रहेछ x को भ्यालु 3 चाहिँ होइन रहेछ त्यसो भए के चाहिँ रहेछ त भन्दाखेरि therefore x belonging in यसो गरौँ न है x equals to 3y minus 1 divided by y 3y minus 2 over y minus 1 this falls in r minus 3 hence f is onto therefore f is bijective this was tuition hence proved